Hello one and all, and welcome to the Math Magic Show. In this one we're going to learn how to make a graph of the following function. So f of x equals -1 divided by the square root of 4 minus x squared. Sometimes in this context it might be helpful to rewrite this in the bottom as under the root symbol 2 minus x multiplying 2 plus x, and that's just because 4 minus x squared is the difference of two squares, so you can factor it into that pattern. And this form is useful because where it says 2 minus x, you see that if you replace x with 2, you would have 2 minus 2, which is 0. That would be not defined, right? Here where it says 2 plus x, if you replace x with -2, you would have 2 minus 2, which is 0 again. That would cause another, so that again would cause the function to be undefined. So you want to factor because the factoring sometimes shows additional pieces of information that may not necessarily be obvious. Let's take a look at building up a graph of this though. So it's going to look like this. Here's our grid. Here's our usual x-axis, vertical axis. Now let's take a look at what happens at -2 itself. So at -2, when you plug that into the function, that's going to look like this. You're going to have -2 minus 2 multiplying 2 minus 2. That's going to give you -1 over -4. But -4 times 0 is 0, so you end up with d and e. So that's telling us that at x equals -2, there's a vertical asymptote essentially. Often asymptotes are indicated by dashed lines, just the way this one is here. So that's one thing that can happen. That is the -2 case. Now on the right side, something similar will happen over here. Take a look. So when I try to replace x with +2, I have -1 over 2 minus 2 multiplying 2 plus 2. Again, 2 minus 2 will be 0, so I end up with -1 over 0, which is d and e. So that's telling me that at x equals +2 right here, I'm going to have another vertical asymptote. So I have two asymptotes. The next thing that usually we often do is see what happens at x equals 0. So when I do that here, I'm going to have the following. Take a look. When I plug that into the function, I have the following. F of 0, in other words, would be equal to -1 over the root of 4 minus 0 squared. That gives -1 over the root of 4, which is -1/2. So that black dot is at -1/2 along the y-axis. Another thing that's often interesting is to understand what happens when you feed values into the function that are close to the asymptote. So in other words, let's grab a value that is very close but slightly to the right of x equals -2. So when I do that, take a look. I'm going to have the following. Let's go to this. Calculation. F of -1.99. There's nothing special about choosing -1.99. I could have chosen -1.9. Just some value that's pretty close to the x equals -2, which is where the asymptote is located. Alright, you plug that into the functions, it's going to give you -1 over the square root of 4 minus -1.99 squared. Because the value of x is a negative number, you want to make sure that it's enclosed within parentheses. So you do the squaring correctly, so we'll have done -1 over the root of 4 minus 3.9601. Do the subtraction. That's this little number here, the root of 0.0399. Take the square root and divide that into -1. When you do that, you end up with -5.0, also about -5. So we can indicate that by kind of putting, for example, an arrow. The top of this arrow right here, where I am, the top of this arrow, that pretty much kind of indicates your input. So that's like roughly at x equals -1.99. And then you follow that arrow down, and that gives you then the output. So in this case, that's about that brown point. Okay, now let's take a look at what happens on the right side. So I'm going to choose a value of x on the right side of the graph that is just slightly to the left of the vertical asymptote, slightly to the left. So as an example, I can do this one. Take a look. I'm going to have f of 1.99. So 1.99 is my input value. I plug it into the function. I go through my calculation here. You can look at it. It's in fact the same thing as on the left side in terms of what you get at the very end. And the reason for that is right here, you're squaring. So when you square something, it doesn't matter whether the input is positive or negative. It ends up being positive anyway. So I would end up with the following, -5.00 and so on. That negative is present because you see at this step it says -1 divided by the quantity under the root symbol. If you look carefully, you see like this step right here on the right side and the step right here on the left side, those two steps are identical. But the outputs are pretty much identical. Alright, so with that in place, we can indicate that by basically now drawing like a little arrow. And again, let me stress this. At the top of this arrow right here, that's like 1.99, so the value slightly to the left of the vertical asymptote. And then the bottom of the arrow, that tells you what the output is along the y-axis right here. We can indicate that, for example, by drawing a little point like that, so the green point. So we've gone through all of these calculations, and we have basically 3 points. Let me emphasize that. So we have this brown point over here, then we have that black point up there across the top, and then we have this little green point on the right side. If you wanted to be more careful, it is true that, for example, I could plug in an intermediate value of x. So maybe something like this right here. See this? And then also over here, another value of x, maybe from about here. But I've done this enough times to know what the shape is. So specifically, that's going to tell us the following, that when I draw in the shape of the graph, on the left side it looks like that. So let me slow down here and make sure I trace over it. This is the graph on the left side. Looks like this, you see? And here I stop it at the brown point, but in reality you gotta imagine that the graph extends forever downwards towards negative infinity. Just keep that in mind. Okay, on the right side, same thing will happen. So when I draw that piece of the graph, see, it looks like that. So again, same principle applies. I drew the graph this way, and it seems to stop at the green point, but again, that's just because I chose to graph it this way. In reality, the graph extends forever towards negative infinities. And on both sides, do not cross the vertical asymptotes. That's a whole separate video. I know we're often told that don't cross asymptotes, but there's obviously a reason for it, because it would mean something if you did actually cross it. You'd be figuring out how to divide by 0, you see? So you'd be able to assign a value to that somehow. But nobody has been able to do that just yet. Let me remove some of the arrows and clean up the pictures. So that looks like this. This is how you might see it, for example, in the book. Thank you so much for watching. Please leave a like and subscribe. I appreciate the fact that you have spent some time with me. I hope it's been something insightful. I'll see you in another magical adventure.